Hi everyone, I'm Caius, and I created this video to review the idea behind accuracy, recall, precision, and F1 score. I hope this helps clarify the basics of classification metrics, and if you find it useful, please like and share. First things first, let me show you a working classifier on one of the most classical examples, spam classification for emails. To understand how well our classifier is performing, we first need to see the results in a structured way. For this, let's make use of a confusion matrix. It helps us visualize the true positives, true negatives, and false negatives. You may pause the video to comprehend better what exactly this matrix is storing. Now that we've run the simulation, we can compute some performance metrics for a classifier. The most easy to interpret is probably the model accuracy. In this case, the model achieved 40% accuracy, which might seem low at first glance. However, accuracy alone doesn't always tell the full story. For instance, let's say we had a dataset where 95% of the emails are not spam, and our model simply predicts not spam for everything. The accuracy would be very high, but the model would still be failing to actually identify spam emails. This illustrates one of the issues with using accuracy as the sole metric, especially in unbalanced datasets where one class is much more frequent than the other. Precision is relevant when we prioritize minimizing false positives. For example, if you're developing a classifier to filter fraudulent transactions, you may prioritize precision to avoid incorrectly flagging legitimate transactions as fraud. Recall is relevant when we prioritize minimizing false negatives. In a medical context, recall is important when diagnosing rare diseases. Missing a positive case, a false negative, could have severe consequences. The F1 score balances precision and recall by providing a harmonic mean, making it particularly useful when you care about both false positive and false negatives. It helps you understand how well the model is performing in relation to the positive class. One important point to note is that when computing the F1 score, we don't necessarily use the true negatives. This is because the F1 score focuses specifically on the balance between precision and recall. True negatives don't factor into these calculations, since F1 is primarily concerned with the performance on the positive class. This is why the F1 score can be particularly helpful when you have an imbalanced dataset, where the negative class dominates and accuracy may give a misleading impression of the model performance. That's essentially the basics of classification metrics for binary models. Also worth mentioning, AUC and ROC curves are important metrics, particularly for evaluating how well a model separates classes, even in cases with unbalanced datasets. They provide a more detailed analysis of a model performance across different thresholds. Also, when dealing with more than one label, we can expand those concepts we've learned and work with an average, recall, precision, and F1 scores for every label. I'll dive into metrics for multi-class classification in a future video. So if you're interested, make sure to subscribe for more insights.